All right. We are doing counting principles. So when we talk about counting principles, it's where we actually going to talk about objects, alphabets, or the arrangement of objects, the arrangement of alphabets, or even people, or whatever it is that they want us to arrange. So when we talk about counting principles, we're talking about arranging objects, alphabets, assonance, vowels, or whatever it is that they want us to arrange. So what happens is that when they want you to arrange things, they will say repetition is allowed or repetition is not allowed. For an example, let's say we have alphabets. How many alphabets do we have in total? We have 26 alphabets, right? From A to Z. Now, then they say out of the alphabets, the 26, take out the vowels, or how many vowels are found in the alphabets, or how many assonants. But we're going to actually explain all of that stuff. But it's very, very important that when we talk about counting principles, we are talking about the arrangements of objects, of alphabets, of people, and etc. So the most important thing here, you must know what vowels are. You must know what assonants are. That's very, very important. Those are the basics that you know from grade R, or even before you went to grade R. You actually knew this. Let's say we have 1, 2, 3, 4, 5, 6, and 7. Then they give you these numbers or these digits. You can arrange digits, right? Then they say you must form pins or password. Let me just say pin. You must form a 4-digit pin, maybe for your cell phone or for your ATM card. For what? For anything that might actually need you to unlock it using a pin. Then they give you all these numbers. They want you to form a 4-digit pin, and they say that repetition is allowed. When they say that repetition is allowed, it means that you can repeat all the numbers that you want to repeat. But if they say the repetition is not allowed, it means that you must not repeat any number. You take it out, it's like you are not replacing it back. I hope you understand that. For an example, let's say you form this one 1 1 1 1, 4 digits. So repetition is allowed. Why? Because you repeated what, or you actually use same numbers, because they say repetition is allowed. You can use 2 2 2 2 or 1 2 2 2. Why? Because repetition is allowed. Or you can say 4 5 6 6. You repeated this 6 digits, right? Why? Because they said repetition is allowed. But if they say repetition is not allowed, it means that you cannot actually repeat digits. You use it and you don't put it back. It's like you're doing it without replacement, as we're doing the time we're actually explaining the tree diagram. I hope it makes sense. But here we are arranging what? Objects. We talk about arrangements. So let's say we have 5 and 2. They want us to form a 2-digit pin out of these two numbers. So how many numbers do we have? We have 2. So the possible arrangement here that we're going to have 2 of them, because it will be 52 or 25. So these are the 2-digit pins that I'm having. I hope it makes sense. So we have 1 and we have 2. So how many 2 arrangements do we have here? We have 2 arrangements, because they will never ask how many pins. They will ask the arrangement of pins that can be able to be made here. 2 of them. It can be 52 or 25. I hope it makes sense. So we have these 2 spaces. How many digits do we have? We have 2. So I write the 2 here. Now when I actually choose this one, then they say repetition is not allowed. I choose this one. Then how many pins am I left with? I only have 1. So put that 1 there. Then 2 times 1, you'll get what? You'll get 2. It means that we have 2 arrangements. I hope it makes sense. So I have something known as a factorial. a factorial. It helps us to actually be able to calculate our arrangements in a more simpler way or shorter way. For an example, let's say we have 3 factorial. So this factorial means that 3 times 2, not 3, this 3 times 2 times 1, then it gives us the answer. So we have 4 factorial. 4 factorial, it's 4 times 3 times 2 and times 1. I hope it makes sense. So it makes us to be able to calculate our arrangements easily. So this is known as a factorial. I hope it makes sense. It's not an exclamation mark. Remember, this is not English. All right. I hope it made sense. Let's say we have 1, 2, 3, 4, 5, 6, and 7. Now they ask us about the number, about the arrangements. How many arrangements or how many pins can be formed by arranging these digits here. Then they say repetition is not allowed. We have 7 spaces, we have 7 of digits here. Now when I choose one number, how many digits will I be left with? I will have 6 of them, right? Then if I choose another number, remember repetition is not allowed, so we take it out and we don't actually put it back. We'll have 5 of them. When I choose, you can choose any number. When I choose this one, it means that I have 3 digits that are left. When I choose the 5, or let's just say the 6, we are left with 2. Then when I choose the 6, we are left with what? With 1. I hope it makes sense. Therefore, these are the arrangements of the pins that you can actually have when repetition is not allowed. Then they ask you about arrangements. You can actually say 7 factorial instead of writing all of that. I hope it makes sense. So we have what? 7 factorial. Then you can punch that in your calculator to give you the answer. Then that answer, it will be the number of what? Of the arrangements that can be made out of these 7 digits. I hope it makes sense. This is very, very important. If you didn't understand it, make sure that you rewind the video and try to listen to it again. It's very, very important.